Okay, so we're going to look at binomial expansion using Pascal's triangle, which is this thing here. This is Pascal's triangle, and it's built up of rows. You see each row, as you go down, you have to add the next two numbers to get the one after it. So for this column, imagining there's zeros at either side. 0 plus 1 is 1. 1 plus 1 is 2, 0 plus 1 is 2, forming this row. But we don't really need to memorize this because on your calculator you've got something called the choose function, which can get you this, but we'll look at that later. For now, we'll just use this triangle. So looking at this example 1 from the textbook, we can use Pascal's triangle to find the expansions of these two things. Starting with A, we're going to go with x plus 2y cubed, and for the cubed, we want the cubic row of Pascal's triangle. It's like knocks down one, so this would be the x row, this would be the x squared row, this would be the x cubed row, because it falls down. It falls down quite nicely. So taking this row, what I would do is I would always write a list like this: 1, 3, 3, 1. I'd open up pairs of brackets on either side, and it's very formulaic. There is not much problem solving to this. I throw in my x's into one side, my 2y's into one side, and if you understand how Pascal's triangle works, you just do this: 3, 2, 1, 0, 1, 0, 0, 1, 2, 3. And then you just expand it. So you're going to have, and then that is, you put it all back together, plus 6x squared y, plus 12 xy squared, plus 8x y cubed, and that would be our expansion. Okay, so for example B, we're looking for the fourth row of Pascal's triangle, because it's the fourth power. We're looking for the x to the 4 row, which is this one: 1, 4, 6, 4, 1. This is a bit of a longer one: 1, 4, 6, 4, 1. And it wants us to find expansions of these full expansions. A question will never ask you to do the full expansion. It'll only ever ask for the first 4 or 3 terms, which is good. That's nice. So once again, we're going to open our brackets like this. Let's put 2x. And open more brackets and put in the minus 5. And then we're going to have, it's a 4, so we're going to go 4, 3, 2, 1, 0. You have to include 0, 0, 1, 2, 3, 4. And you always go backwards and forwards so they'll line up. It's really nice. And this is a formula that's given in the formula book if you want to see how it works. But for binomial, I really do not think it's important. So for this, we're just going to jump straight to the answer. We're going to have 60 next to the 4. We're going to have 8 times 4 is 32. Times minus 5, so we're going to have 32 times minus 5 x cubed. Then we're going to have 4 times 6 is 24, so we're going to have 24. And then minus 5 squared is 25. Then we're going to have 4 times 2 is 8, minus 5 cubed x. And then this is going to be 1, so then it's going to be x, so it's going to be minus 5 to the 4. And then all I'm going to do is I'm going to type that into my calculator and it will give me an answer. And that would be the answer. So that's a very basic introduction to Pascal's triangle. There's really not much to it. It's one of the easiest topics to do at A-level maths, and I believe it's also in GCSE further maths, so there is some crossover. That is section 8.1 of binomial.